Good morning, everyone. So welcome to the second day of Cassandra Summit. It's a great summit so far, I thought. Biggest NoSQL conference in the world. Today I'm going to talk about some of the Cassandra use cases at Proofpoint, and hopefully they might inspire some of your use cases. So there's a bunch of different use cases we have at Proofpoint. Let me start off by just talking about a little bit about me. I'm a data scientist and data engineer, and I'm responsible for the content classification and some of the fraudulent and anomaly detection and security research. I work with the engineering, marketing, and research teams at Proofpoint. So about a year ago, I gave a talk at Cassandra Summit. At the time, I was working for Nextgate. So Nextgate is a social media security and compliance company. About a few months after that talk, Nextgate was acquired by Proofpoint. And in hindsight, I can say that it was due in large part to the stable infrastructure and reliable performance of Cassandra that was Nextgate's success and its continued success within Proofpoint. A quick outline of this talk. I'll give a little bit of a background about Proofpoint and then talk about the many use cases of Cassandra at Proofpoint. You might notice that I've separated into two sections, so email security and then social media security and compliance, of which I'm more involved with. Before I begin, though, I have to give credit to a lot of the people whose work is being talked about in these slides. So I want to mention the following people, my Proofpoint colleagues: Brian Burns, Brian Hawkins, Wayne Lewis, Andy Moss, Anand Samani, Greg Saylor, and Rich Sutton. Proofpoint is a cybersecurity that focuses in the email, social media, and mobile space. It's been around since 2002, and there's over 1,000 employees. So it's a sizable number of people at Cassandra, and as such, there's a lot of use cases for Cassandra at Proofpoint. And some of these use cases might seem different from each other, although they fall under the umbrella of security. But I hope you take away that all the use cases take advantage of Cassandra's features. So let's start with the email security and compliance space. How to use Cassandra in email. Before I begin with the first use case of Cassandra in email, I want to talk about the product that it supports to gain a better appreciation for that product. So there's a product in Proofpoint called TAP. It stands for Targeted Attack Protection. And a targeted attack is an attack that's organized around an individual or an organization. So the way it works is it analyzes the URLs, attachments, and user clicks in an email message. And there's a Cassandra table. Let me talk about an article that recently came up that highlights the powerfulness of TAP. So just last week, there was a campaign against the Russian military. So imagine you're a Russian militant, and you're part of the Russian military. You receive an email. You receive the email, and in the email, there's an attachment to a Word document. So you open up that Word document because your antivirus, all your antivirus is passed. There's no virus on that document. You open it up and you read it, and it talks about Russian military history. And you're interested because you're part of the Russian military. Once you finish reading it, you close it, and then you never think about it again. So what actually happened when you closed that document was it triggered a second file to download a third file, and this third file is where the nasty stuff comes in. Now the antivirus would have not caught that because there's no virus in the document. This is a common anti-sandboxing technique that a lot of sandboxes miss. But TAP is a product that would have caught that. So the reason why TAP is so powerful is because it's supported by Cassandra. So the way Cassandra is used with TAP is that it's basically used as an indexer. It hashes the URL and then stores the metadata of the email message in the columns. And these email messages can be used to determine what are the email messages across all our customers that contain this URL. So if the URL is malicious, we can find out all the messages that had that malicious URL. Furthermore, we can use the metadata in the email message to map back to the content itself. so that we can display on a dashboard what kind of message it was, in case there are other messages similar to that message, but with a different URL. The Cassandra infrastructure for TAP is a 40-node cluster in AWS with C32X larges. It's about 2 terabytes of EBS storage on each. There's a replication factor of 4, and data has increased about 100% since last year. KairosDB, which is a time series database built on top of Cassandra, plays a huge part in our monitoring our metrics. So it's become pretty critical to Proofpoint to be able to monitor JMX metrics. JMX, are, if you don't know, are things that report back CPU or memory. And there's about 14 billion metrics a month across thousands of machines. So TAP has been a pretty powerful part of Proofpoint, and it's been supported by Cassandra. Another thing we have for email is something we call internally the threat database. Now we're getting a lot of data from email and then from TAP, but we don't have a way of correlating all these data points. So we decided to build a custom graph database on top of Cassandra. Now this graph database, we used row key as the vertex and the columns as the edges. There's 18 nodes, 24 terabytes of data, and then at its highest peak, there's about 1 million events per second. And it was actually successfully used to detect campaigns that couldn't have been detected otherwise. So there is actually a network effect out there. One of the campaigns we detected you might have heard of or might not have heard of is the Dridex campaign. And when I mention a custom graph database, you might be asking, why don't we just go use TitanDB? I think the simple answer is, at the time, it wasn't as much integration with TitanDB and Cassandra, and that is apparently coming. In one of the future versions of DataStax Enterprise, Titan's going to be integrated with Cassandra, so we are looking forward to that. Just to dive a little deeper, though, at the time, a lot of these graph databases generated their own IDs, and that caused us to have a lot of unnecessary querying. And so it killed our insert performance, so we just wanted to write something that was custom and fit for our use case. But one of the designs that is similar to Titan is that all of the edges on the same vertex live on the same node. I do think, though, with the integration of Titan and Cassandra and the future releases of DataStax Enterprise, some of the ID problems might be resolved. Another use case we have for Cassandra and email is as a general purpose infrastructure storage. So we store attachments as large encrypted blobs in a product called Secure Share, which allows customers to securely share files and emails with each other. Some of these files range between 20 megabytes and 2 gigabytes. It's also used as an identity store, so we might store users and customer information in there. It's about there's 6 nodes across 2 data centers, 3 nodes in each data center. And the idea, why we could have stored this in SQL, but we wanted to use Cassandra because of its distributed nature. It'd be easy to scale up if we needed to. And lastly, one of the use cases we have in email for Cassandra is a research-focused one. This is a project that came out of Hack Day, which people wanted to use the ability of Spark and Cassandra together. In this case, we wanted to cluster email topics together. And the way we did that was by using a Spark streaming algorithm, using the Spark library MLlib. We used the K means clustering algorithm, using the word2vec as a means of clustering. So we started with K equals 20, 50, and 100, just because we weren't sure what kind of clusters were the best. But it turns out that using word2vec was great for clustering because a lot of the topics that are synonymous with each other live in the same vector space. So we actually found that a lot of some of the clusters formed around spam, and this could be used later on to determine what's later on to, so right now it's in the research phase, but it can be used later on to determine what are the topics that are clustering. So now I want to jump into Cassandra for social media, so which I am more directly a part of. Our main motivation behind Cassandra for social media is that we wanted to store everything. One of the main applications in our product, the Nextgate social media product of Proofpoint, is classification. So in order to have a great classification system, we needed to have an accurate classification system. In order to have an accurate classification system, we needed to train it on a lot of the data And in order to have a lot of data, we need to store that data. And so Cassandra, being able to store all that data was a great choice for us because Cassandra is easy to use, easy to scale, had a powerful data model, and there's a great community behind it. So looking back, we do think that we made a great choice in Cassandra. And so this is what, sorry. I'm sorry?
What classification is that?
Attric. Social media classification. So just to give a little insight into our classification in social media, we have over 100 classifiers. We classify spam, profanity, threats, FINRA compliance violations, HIPAA violations. So there's a bunch of classifiers, and so we needed a good classification system. And we need to store all that data, so that's why we use Cassandra to store all that data. Yeah. So this is what we currently have in production on the social media side. It's about 2 terabytes of data across 3 data centers. Our current rate is 150 writes and 15 reads per second, which is great because Cassandra is made for fast writes, so it's great that our writes are better, faster, more than our reads. And it's interesting to talk about how we got here. When we started with Cassandra in 2012, we were using Cassandra 1.16 with Ubuntu 10.04. It was only in 1 data center with 3 nodes, and we're using M1 larges. And today, we're using DataStax Enterprise 4.5.7 with Ubuntu 14.04. We have 3 data centers with 9 nodes, and we have Solar deployed in one of the data centers. We're now using solid-state drives, and we have over 500 million content stored. So Chuck Norris, while drinking his Pepsi, would approve that, that it never gone down. So Cassandra has never gone down for us, and I've noticed that some of the people at Cassandra Summit are wearing shirts that say never gone down, and I really wish I could have got one of those shirts for this slide. But I swear to you that I wrote this slide before I saw those shirts. That makes me think that we can attest that that's true. So Cassandra has never gone down. In fact, we had, I think, more issues with SQL than Cassandra going down, but not that long. One of the first use cases I want to talk about for social media is that we are going global with our databases. As our customer base grows, so do our feature requests. And one of the feature requests is that data should be kept in a particular region. For instance, we might have a European company that wants to keep their data in Europe. And we're doing this by having a dedicated global Cassandra cluster. And the way it works is that each of those circles represents local regions, local data centers that talk to our local Nextgate application. And so we might have, for instance, a MySQL database in there, a local Cassandra database in there, but it will benefit from other local databases by going through this global database. So just to give you an example, we have something called a global spamming users list. And the spamming users list calculates authors that are spammers in their local region. So each local region can benefit from another local region's spamming users list by talking to that global data center that you see that's connected by the red arrows. Another thing we use for global data centers is a clever user authentication system. Can't go into too much of the details, but it's similar to 2FA, and we're using the nice feature of Cassandra that it's distributed and also its TTL feature. And this is what our global data center looks like right now. There's 2 nodes and 3 data centers. There's not a lot of data, but the important thing is that it's enabling our application, solving our feature requests, and doesn't take a lot of setup time. Okay, our 6th use case on social media is for detecting spam. So in the email world, spam is very familiar. It may not be a completely solved problem, but at least it's familiar. And in the email world, basically whenever you send one message, it's a one send, one recipient kind of model, so 1-to-1. But in social media, a single post on an active Facebook page can get up to 1 million views if there's 1 million followers on that Facebook page. And when you start posting the same content on different active Facebook accounts, that starts to add up. So we wanted to find a way to detect repeated content spam messages, and we did that through Cassandra data modeling. So this simple Cassandra data model allowed us to query in real time the repeated content. So this is how we did it. We take the social media content, hash it, put it as a row key, and then the column names are the metadata of that social media content. So that could include things like the timestamp and then the item identifier, which can map back to other things about that content. It's not enough that we find out how many times, so with this data model, you can count the number of columns on that row key, and you get back how many times that content has been seen. It's not enough to see how many times that content has been seen to flag it as spam. So that's why we include this metadata in the column names. We can go back and do offline analysis. We might be able to do time series analysis to find patterns or content analysis, which is important because sometimes you might get a multiple choice question on the social media page, and the answers could be A, B, 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 C, B, B, B. So you get a lot of the repeated content as the letter B, but that's not bad. So we want to go back and retune our repeated content spam algorithms to perhaps put a threshold on the number of words or number of characters, things like that. So that's been pretty powerful. It's caught a lot of spammers and a lot of spam. And this was just using one Cassandra data model. And we could do it in real time. Another use case we have for social media with Cassandra is trending topics. So sometimes a brand or company might announce the release of a product. Maybe if you're a movie and there's a DVD release announcement coming, you might get a lot of people coming onto that Facebook page to post their views and opinions about, yay, this DVD is coming out on a certain date. So the spammers take advantage of the fact that there's a lot of eyes around this activity, and so there's a burst in activity. We wanted to create a Cassandra data model that could detect this burst in activity. So we call it social mob or a spike in the activity. But it's not enough to know that there's a spike in activity because sometimes, and this happens quite often for us, it's a benign spike. You might have someone's birthday, so you get a lot of people saying happy birthday, and there's a huge spike in activity, but it's not so bad. So it's not enough to know that there's a spike in the time series data. We also are interested in the content of it too. And the cool thing about this use case is that a single Cassandra data model can solve both of those cases. You can find out when the spike is happening and what it's talking about. So let's go into that data model a little bit. It's actually just a textbook use case for Cassandra in time series modeling. The goal is to get the number of times a topic has been talked about in an arbitrary period of time. So the way we do that is we use a composite partition key, which is the account ID and the year, month that the message was posted. This ensures that all the data from the same account in the same time period will live on the same node. So that makes for faster querying. And then the rest of the column names will include things that we would like to query on. So that we include the timestamp down to the minute, which means that we can now query the time range down to the minute, not just the month on the row key. We also include the topic so that we can now know what topics are being talked about. And then we include the item identifier so that we can map back to what the topic actually is, the contents of this message, things like I said before in the other slide. We can look back to who's posted it, the time, do time series analysis offline, et cetera. So the topic I just want to mention real quickly is determined by looking at the bigrams of the content and removing all the stop words. So it's very simple topic analysis. And this has been very useful for finding outbreaks of spam campaigns, as well as happy birthday messages. Okay, so our last use case is with archive search. Basically, by using some of the tools in DataStax Enterprise, we've been able to build a lightweight version of archive search on social media. So this has fulfilled a lot of our compliance requests from customers. They can go ahead and search throughout all the posts they've ever made or comments that's been made on their page just by doing open-ended searches. So I wanted to mention finally that with this use case, by combining this use case with the previous use case, we've actually created a very powerful moderation tool. What happened just last week was that we found a spam campaign through our trending topics about weight loss pills. So it occurred on some account. There was a spike in activity, weight loss pills. And then we used archive search to search for some of these keywords in that campaign. And we were able to moderate all the other accounts that also had this campaign. So by combining these two tools together, made for a very powerful moderation tool. And they're both powered by Cassandra. So in summary, the key use cases I wanted to highlight were that there's a lot of different use cases that we have at Proofpoint, but they're all combined by using a lot of the use cases we use with Cassandra at Proofpoint, but they're all tied together by using the features of Cassandra. So some of these use cases took advantage of the data modeling Cassandra. Some of these took advantage of distributed nature. And then other tools can easily plug in, like Solar and Spark, the fact that it's easy to use, and that there's amazing community support. So that concludes my talk. So thanks, DataStax, for hosting the event, and thanks for everyone joining me today. Are there any questions? Yes. Multi-tenancy. So I actually don't know. I actually have, the CTO of Nextgate is here today. So if he knows the answer to that.
Yeah, hello.
Yeah, so I have to admit, a lot of the operations questions I might have to relay
No,
over to the
One
CTO.
question here, in some of the use cases, right, how do you inject those data which is coming, right, in real time into the Cassandra? I mean, can you just brief us, like, how do you inject the data directly into Cassandra? Like, for example, email, tweets, or social media data, right, which you want to do. How do you inject the data into the Cassandra?
How do we inject our data to Cassandra? So I can definitely speak on the social media side, I think, but not for the email. But for social media, how do we inject our data in Cassandra? So our application is built on top of Rails, and we can, if we're installed on a Facebook page, we will we have real-time updates, and as soon as the content comes in, we just write it straight to Cassandra. We have other abilities, like something called on-demand scan, where we look at the content kind of retroactively, and that it's just inserted into Cassandra as it's being captured through the Rails app.
This was a good presentation. Thank you very much.
Thank you.
I wanted to go back to the second last use case you had on the benign spikes, between the difference between a happy birthday and a nasty comment. And you said something about the way you parse it, or which I missed, that how you differentiate between benign and non-benign.
Right.
And I have a follow-up question to that.
Yeah, sure. Okay, so the question to that is that it's actually being sent as an email alert, and so we're doing this manually right now, and we're going to find a way to look at more features to determine when a topic is benign versus when it's bad. But at the moment, we're getting alerts on trending topics. So we're looking at, we get the list of top 10 topics whenever there's a spike, and then we can alert to the user that, oh, something is happening.
So the
It's
follow-up.
very manually.
Okay, so the follow-up question is, part of your solution, would it include building a dynamic dictionary based on a histogram or frequency as a model to populate the nouns in the dictionary?
Absolutely. That's one great idea. We could definitely do that. Yeah.
Okay. So then I have one more follow-up question.
Sure.
So how would you, so Cassandra is all about persistent store.
Okay.
Right? So you have incoming stream, you store it, and then you retrieve it through an application interface. Where do your models live, and how would you apply those models to the incoming stream as well as the historical data?
Sorry, I don't understand the question.
Okay, so you have persistently stored the data, say 100,000 tweets or Facebook posts in the last 1 hour, for example.
Okay.
Now, do you go back and look at it again to find out benign, non-benign, or does the model live in memory, and as the data is going in, is parsing it and building a pattern or a histogram?
So what we do is, as the data comes in, it's inserted into Cassandra immediately, and then later on, for the training topics job, we might have a job that runs maybe every hour, every half hour to read the data, to query the data model and get back the training topics. In a sense, but it's also inserted as soon as the data comes in too. It's kind of munged a little bit. Yeah.
Thank you.
Yeah, sure.
Any other questions? We got one back here.
Yeah, in the threat database, you talked about storing a graph and storing things in Cassandra with the keys as vertices and the edges as columns. Are you keeping back edges to the vertexes?
Oh, what was the last part? Can you repeat the last part
Are
again?
you keeping back edges so to each vertex?
That's a great question. I actually don't know the answer to that. Can you repeat the question?
So in the threat database, you're storing a graph, right? And you're storing each row has a key, and that's the vertex, and each of its edges outbound are columns, right? So you're using the wide rows, correct? And I was just wondering if you were storing back edges to each of the vertexes.
That's a great question. So I actually don't work on the team that designed this, but I can definitely get back to you on how they do that, if
Okay.
they use back edges.
Great.
Yeah.
Thanks.
I actually have a question for you too,
Yes.
Harold. Do you guys encrypt all of your data at rest?
Encrypt all our data at rest. Yes.
You do? And for that, what exactly do you use? Or do you use any of the encryption methods offered by DataStax Enterprise?
Okay.
It's kind of my question.
was the man for that.
So sadly, no, we don't use the encryption from Cassandra or from DataStax, and part of the reason of that is because, as you saw, we've been deployed with Cassandra for a long time in production, right, since 2012. So that's one of the aspects of DataStax Enterprise that we have not deployed. We use third-party tools to do disk encryption of in this case, these are instance-attached drives, which is much faster than EBS volumes, and you can only use AWS disk encryption on EBS volumes. So we actually have third-party technology to do disk encryption that we use. So the question is, what is the use case that drives the encryption? The use case is, number one, it's just a bad idea to not encrypt your data on disks in Amazon, right? Those disks get recycled, and there are reports of sometimes an instance attached storage getting attached to a new instance and has the old data on it. I think Amazon's better about that in 2015 than maybe they were in 2012. But the second is that, you know, the companies that buy our product are large enterprises. They're the Visas and the Wells Fargos of the world, and they expect us to take the security of our application and the data that we store seriously. And so we encrypt our data because it's the right thing to do when you are selling enterprise applications.
Thank you. Any other questions? All right, well, let's give Harold a round of applause. It was a great talk.
Thanks, everyone.